will be the darkest. That will be most centrally in the umbra. The bottom should be the lightest, maybe yellow, maybe different colors. Plus, it's going to change as the eclipse goes on, because once the moon is fully in our shadow, it's going to stay there for, I think, an hour and 13 minutes. So then it's going to start 2 minutes from now. So why don't you help guide us a little bit on these final 2 minutes of sunlight? What are you seeing now that the rest of us should be paying attention to?
Well, this view of the United Kingdom is actually a really good one because it's very close up. And it's, again, really hard to see these things because, I mean, we're just looking at the contrast between the very, very bright little edge of the moon on the bottom there and the rest of it, which is getting darker. But if you really focus on the part that's right on the edge of that brightness, you can almost catch a bluish tinge. It's very hard to detect. I mean, it may even be something I'm just seeing because I've looked at other pictures and seen.
No, I see that too. I see that too.
It's very, very faint, but it's there.
I think it's very distinct. But the question is, if you were looking at the moon directly yourself or with binoculars and not using any photographic techniques, would it look blue? That would really be the question. There's not much left.
We'd probably take using a telescope, as they're using it here in the UK, to get a very, very close-up view of it, because otherwise it would just be too much of a contrast, too distant away to really see that for yourself just with the naked eye.
Yes, and now we've got just seconds left. The moon traveling at 2,280 miles an hour. That's several times the speed of sound. It's even faster than the Concorde used to fly, and at that orbital speed around Earth, carrying it around in 27 and the third days roughly, it's about to pass into our shadow. Now we only have 30 seconds left, and then the eclipse will be fully immersed in our umbral shadow. And at that point, what we see is a big function of the kind of
Buffering.
of the kind of exposure that we give it. Now we have a number of feed partners along with our giant slew telescopes. So look at this view, for example. In this view, where the exposure is a little different, so that you can't even see any trace of reddishness. Whereas if you went outside and looked at the moon right now, I can assure you, because I just did that a few minutes ago, the moon looks red. How about you, where you are, Scott, in Canada? Do you have a moon in your sky, or is it cloudy?
Unfortunately, a lot of cloud moved into southern Ontario, and so we're only seeing it in little tiny breaks between those, and we're hoping for a slightly larger break to come in, hopefully during totality, so that we can see the red moon in its full. But it's dicey at the moment, unfortunately.
And we've got it. We've diced it up. Here is we've reached hemogenesis, the moment of the blood moon's beginning. Actually, we've been seeing it looking red, of course, as we've approached totality, but here we are. We have reached totality. Look at that yummy, scrumptious unevenness in the lighting.
It's scrumptious? Apparently so.